Okay, so we're back. I'm going to talk about item discrimination. So, item discrimination is different from item difficulty. It would be very good, wink, wink, you can't really see it as a fish, to be able to explain the differences between those two. But anyway, item discrimination is the degree to which each item differentiates correctly among test takers with regard to the behavior that test is designed to measure. So evaluating discrimination depends upon the nature and purpose of the test. I kind of hinted at this previously, and it can be based on the criterion external to the test, or by using the total score of the test itself as a criterion, or by some combination of both procedures. And just in general, item discrimination indices evaluate the degree to which, oh, I already said this. What is, oh, apparently I have my notes in here twice. Congratulations. All right, discriminability can be defined in at least two ways. Here's the ways we're going to cover in this class. So one, how well does each item discriminate between individuals who score high versus low on the test as a whole? And that can just be any trait of interest or even test performance. I look at these type of statistics all the time when I'm updating and refining my tests, because you can calculate them for short answer essays, but it's a pain. But anyway, yeah, it doesn't just have to be multiple choice, although those are easier. So this can also just be operationalized as how well each item relates to the trait. So we're talking like the factor loadings for factor analysis, like how highly correlated they are with the overall latent trait. And frankly, both of these are pretty much the same thing because they ask the same question or address the same question. The more an item is related to the trait, the better that item is at distinguishing between high and low individuals. And so like these, so these item discrimination procedures that I'm going to kind of go into typically involve the use of contrasting criterion groups and then calculating the computational difference between them, such as the D-index. Now, alternatively, there are correlational techniques such as the phi coefficient that can also be used to assess the relationship between item response and the standing on the criterion. We'll talk about these in a bit. So here's the extreme group method. First, we have to identify our extreme groups. Often this boils down to the top third or the bottom third. It has some problems with it, but the basic idea is to see if your questions are good at distinguishing between those two groups. So what you do is you compute the difficulty for the top group, and then you compute the difficulty for the bottom group. And then you compare the difference between the top group and the bottom group. And this results in the discriminability index. Congratulations. And so here I have a ginormous table that I encourage you to pause and crawl into that breaks down this technique and kind of illustrates it. Looking at let's just take the first item. I prefer to pass by people I know, and about 5 or 56% of people endorse this in the high scorers group, while 5% of people endorse this in the low scorers group. And the difference in that percentage, that essentially the discrimination index, is 0.5. it's the subtraction. So kind of the biggest discriminator, I've got it here in red, is the at parties I'm more likely to sit by myself or blah blah blah. And uh, in the high score group, 85% endorse this, while only 7% endorse this in the low score group. And that spread is huge versus the two below it, which I think is the lowest scoring item in this group. Yes. I'm never happier than when alone. Sure, this is pretty distinguishable. In the high third, we've got 0.24, and in the low third, we've got 0.021. And that difference is 0.2. It's not as big or as shocking as every other method we've looked at. All right, so here's the breakdown of how to do the item total correlation technique. So let's let the total score stand in for the trait of interest. So this is roughly an estimated factor. Effectively, it's a factor where every question is equally weighted. And then we correlate each item with the total test score. So items with higher item total correlations are more discriminating because that item, an increase in item scoring on one question is strongly associated with increases in the overall trait. Low correlations or negative correlations can be problematic, although with a negative correlation you can just flip it. But that's the idea. Now the point by serial method, so if you have dichotomously scored items, so think like the MMPI or items with a correct answer, you can correlate the proportion of people getting each item correct with the total test score. That's actually what I was showing you earlier. And here it's one dichotomous variable, so correct, incorrect, is correlated with a continuous variable, the total score. Hence we use a point by serial correlation. And this measures discriminability. Oh, I lied. Here it is. Here's the item total correlations. You can combine these tables if you'd like. It does get a little overwhelming, I'm not gonna lie. But feel free to crawl in. Now, the discrimination index here can also be standardized into a z-value. It's 1/2 of the natural log of 1 plus our correlation minus the natural log of 1 minus our correlation. And that'll give us a really nice z-score. Do I have a worked example? Oh, I almost do. So here's a table where it's already been converted. So a correlation of 0.1 gives us a z-score 0.1, 0.25, z-score of 0.255, and this goes up and up. So a correlation of 0.99 gives us a z-score of 2.647. Got a whole giant table of them. I encourage you to do some practice problems to help develop your intuition. And I think this diagram is helpful. So you'll see that these aren't perfectly correlated. I recommend using difficulty and discrimination together to make your choices. Here I've got a diagram illustrating the various locations of between for all the individual items that I've been showing you this entire time. So this item test regression graph allows for the simultaneous representation of item difficulty and discrimination. They provide a picture of the relationship between item performance and total score. And ideally you want questions that are both highly discriminating and of reasonable difficulty. And I've kind of highlighted them in the gray box here, although I'm starting to worry that that box got tilted. But anyway, that's kind of it for the big picture in discrimination for test items. Yes, I know it's unfortunately named. I'll see y'all later. Bye.